Good evening. My name is Andres Arguello. I am a collaborator, a researcher, and a professor at the University of Costa Rica. Particularly, I work in the Electrical Power and Energy Research Laboratory that specializes in studies of power systems and electrical energy. And today I'm bringing you a quick tutorial on how to use the plugins that we developed a few years ago, I would say, and a few months ago, we have updated to use the geographical information systems, specifically the software QGIS, to build electrical models for OpenDSS. So the utilities commonly have their assets controlled in geographical information systems. They can be in software such as ArcGIS or QGIS that we use here in Costa Rica in some cases. In the university, we use this one because it's open source and it's free. So we developed a series of tools that allow us to conduct all this modeling and simulation directly from QGIS instead of building the models by hand and simulating in OpenDSS by hand. So what we are going to do here is go through the basic steps in order to use to install the plugins into QGIS. Then I'm going to share with you an example circuit that has all the minimal requirements that are necessary in order to build the circuits. And then I'm going to run a simple power flow just to check for the power losses of the circuit, okay? So the first thing you have to do is go to this GitHub, that is the EPER-Lab Github, and you will have to download 3 plugins here, okay? You have to download QGIS to OpenDSS plugin, right? You have to download the QGIS run OpenDSS. This one, the first one is used to build the models from the geographical information systems, okay? Everything is built into text files that are input into OpenDSS, and that will be run by this second plugin, okay? The third one is the distribution network corrector, okay? This one is quite useful because you use it in order to correct errors in connection, missing information, in case you have to split lines, for example, 2 lines that are crossing in the geographical information system, but do not have an explicit node within them, may result in disconnections that may come from an unknown source. So this plugin covers all those cases, okay? Actually, all these 3 plugins, they have their respective papers available in IEEE Explorer, and we can go through that a little later, okay? Let's say, for example, that we are going to download this first one. We refer to it commonly here as the blue plugin. Okay, this one's the red, and this one is the corrector. Let's go to this one. And here we go to the code menu, and then we go to download as zip, okay? We download it as zip in order to install it into QGIS. Here we have to go to plugins. I have it in Spanish, so it's complementos, right? But we have to go to plugins menu, and here we go to the plugin management, okay? It takes a little while in order to open, but then we go to this first menu that is install from a zip file. Let's say we have to use one of those that we have downloaded. You can see here that I have downloaded the red one and the blue one, okay? Let's say we choose this one, and all we have to do is click on install. Once everything is installed, it will be quite quick, right? And we have to close this menu. These 3 plugins over here will be shown on your screen, okay? So the logical flow in order to use these plugins is first to check for errors, right? Then to build the models, and finally to run the simulation. But let's go through this project first, okay? in order to use these 3 plugins, you have to create a project, okay? So my project here in QGIS, let's say I build a new one. So I go here, right? And then I load everything that I need here. So that would be like the service cables, the underground low voltage cables, the medium voltage overhead lines, the medium voltage underground lines, the substation, the medium voltage to low voltage transformers, and loads, okay? This one here, the bus VT and the bus MT, those are auxiliary shapefiles that are built from the plugins. Once it calculates all the buses that your model will need, okay? So let's go through the first one, right? Okay. The files that I will give you will have at least these 2 over here, these 2 folders, right? So you go to GIS, and in GIS you will find the XYZ project. It's already built, so all you have to do is double click it, and it will open you with all the loaded shape files that you need. Let's go through the DN corrector then. You can see that I've been already using this plugin, so it's already like loaded. You go to medium voltage lines, you load those lines here. You go to transformers here. If you don't have medium voltage loads, then you don't put anything there. You see that you have 3 slots in every one of these possibilities. Here, for example, I will use as the low voltage lines the secondary, that's overhead secondary, and the low voltage underground. Then in the acometidas here, we have to choose the service cable, that's aqua area in the project that you are using. And then you have to choose the low voltage loads, right? This tolerance is used to set for the connectivity algorithm to check if an element it's supposed to be connected or not, right? I advise you to leave it in 0.1 meters. Do not be too restrictive with it or too lax with it, or you will get improper results. We will check for rings, loops in the medium voltage and the low voltage. So right here, I will check on errors on the medium voltage. One thing I also advise you is to open the Python terminal, because here you will check for errors that the plugins will output, okay? Here you can see that there is a medium voltage loop. That can be an error. Let's check for it. We have highlighted it, so this plugin will tell me where that error can be, okay? Let me check just this. Let me remove the transformers and let me remove the loads so we can have a better visibility. So this red line over here was put as an example, like to force the error, okay? This will not give you any problems in simulation, but maybe a connectivity error in terms of being completely correct, okay? You can edit the layer as it is commonly done in QGIS, or you can leave it just like that. The project will run properly, okay? So that's the first step, to run the corrector. Then you run the blue one. Check out how I am configuring the plugin. So you have to put the name on the file. I'm going to put the same one as the project, that's XYZ. Then you have to choose over here where the load profiles will be, okay? This one as well is another file that I have given you in the examples, okay? So you go through this folder here, DSS, and in this folder, curves, you will see a lot of TXT files with many possibilities of residential loads. Distributed generation here is particularly only the PV profile for PV generators, clean day PV generators. And here you have industrial loads and commercial loads. the plugin will know which one to load, okay? So you have to give it that path, the one with the curves, and that's it. You select the folder. And then you go to the location of the output files. I will use this folder, DSS, okay? Just leave it like that. And then you have to fill it up with the layers of each position. This one is the medium voltage, right, overhead. And if it's underground, you have to check this checkbox. Do the same for the transformers, do the same for the secondary overhead, secondary underground, checkbox. This one is the service cable, and this one is the loads, the low voltage loads. You see that there are no fuses, no reclosers, no medium voltage loads, public lighting. There is no, at least in this example, there are no components of this class. And finally, you have to choose the substation, okay? I will choose it here, and then I can choose to model it if I want it as a transformer, or I can choose not to model it if I only want like an grid equivalent at the secondary of that transformer, okay? Then I click on accept, and it will take a while to do the calculations, and then it will tell you once the files are ready. I will not do it again here because it takes a while, but anyway, the output files will be in the DSS folder. You can see here that you have a master file in DSS, and it will load all the necessary files, right? The loads, the monitors, the energy meters, the lines, for example, here, these are the medium voltage lines that were created from the geographical information system with the respective lengths and the geometry, the material that it goes into the geometry. There are a couple of libraries as well over here that were created automatically from the plugin. For example, this one, let's see the AAAC, for example. So we have the wire data here. I want to see about the geometries. I think it's this one, the config lines. Yep. So here we have the line spacings. These are like the typical ones in Costa Rica, at least. And we have a lot of line geometries. We have performed many studies using these libraries, okay? You can be rest assured that they are correct. We have used them previously. We have validated them, and they are all based on the practices of Costa Rican utilities for medium voltage and low voltage, okay? So once that we have gone through the first two steps, we go to the third one. The third one would be to open the DSS, this one, the run plugin. We call it the red one. And finally, we fill it up. Over here, I'm going to use the same nomenclature. I'm going to use XYZ. You can leave all those spaces as they are, only to run the example. And here, this point is particularly special because you have to choose here, which is the curve that you're going to use as the medium voltage equivalent, okay, at the substation. That specifically is in here. I put it in the curves folder. So you choose the CSV file. You can check it if you want. It has this day, I think 9 September, right? Yeah, that's the September 28, 2014. So we have been running this plugin since 2014, as you can see. And here we have to put the place where we want the DSS files output. Let's say I'm going to put it here in the example folder, right? And finally, we leave it as it is. Okay, we are only going to run a snapshot power flow. We click on accept, and it's going to take a while. but it's going to inform us about the progress it is doing. It does its load allocation. It checks for the losses, and once it ends, it's going to show you a TXT file that is typical from OpenDSS about the losses. Okay, and here you will have the source was just to check the voltages in magnitude and in PU. Okay, I think this is the voltages and this is the currents. Yeah, this is the voltages in PU and the currents in amperes, I think it is. So as you can see, the circuit is unbalanced, as expected from medium voltage and low voltage distribution system. In Costa Rica, particularly, we use the split phase, a single phase transformer, right? And we have three phase distribution in medium voltage, and in low voltage, we have single phase systems mostly, okay? So, yep, all the output files will be here in DSS. You can check them in detail. I hope this tutorial has been helpful. I know it's quite a lot to chew, like in one go. But if you need anything, you may contact me or leave it as a comment in the video. I will leave my email as well in the description of the video. And I hope you have a good evening. Okay, see you.